Hello, my name is Peter Webb. I apologize for the absence of Drew Thomas. He's currently traveling to China right now for another job, and he's not going to be able to participate in this video, but he will be there for our final pitch. MARSfarm. An early-stage ag-ed startup, MARSfarm designs computer-integrated plant growth chambers running open-source software and project-based STEM curriculum. Farmers of the future will need to provide more with less as population increases and people continue to move towards cities. The FAO predicts that food production must increase 70% by the year 2050. Traditional education is insufficient at getting the next generation engaged, and it's not prepared to fill the gap left by those leaving the agricultural workforce. My generation all around the world is moving to cities and leaving their farms. The current agricultural system is changing to cope, and farming will become more digital and require different skills in the future. I believe St. Louis can lead the world with the next agricultural revolution by working with the next generation of farmers to develop the tools they will need. I hope MARSfarm will help to coordinate that effort by giving us a common, while ambitious, goal of one day growing plants on Mars. Since we aren't Silicon Valley billionaires, starting a space company is really hard. So, we're seeking to get our start in education. My name is Peter Webb. I'm currently a full-time employee at Husband Refrigeration. Husband is a subsidiary of Panasonic, and I was previously the community liaison for the Open Agriculture Foundation. I'm a St. Louis native, and I was homeschooled my entire life. I was previously a tech shop entrepreneur in residence, which is where I met Drew. And we actually met due to me working on a food computer project, so building a plant growth chamber there at Tech Shop. Drew was a CNC instructor at Tech Shop and a full-time CNC machinist. He works for a company prototyping parts for the aerospace industry primarily. He grew up in rural Missouri and is no stranger to agriculture or building things. He's operating as a private consultant for Quip, which is a startup manufacturing subscription-based toothbrushes, and he's offering assistance on outsourcing their projects to China. Together, with the help of other collaborators, we developed the MVP food computer and released it to the Open Ag MIT community. Since then, it's been built by 50 people around the world, and our thread is the most viewed thread on the entire forums, ever. STEM is now required by state legislation in high school for Missouri, which is a common trend that we're seeing at levels all around states in the United States. We see STEM education in the U.S. to be a massive opportunity, and so we prefer to take a bottom-up approach when sizing our market. Rather than trying to sell directly into schools, we want to work with partner organizations to drive our products into schools through partnerships and customized modules. We see some of these organizations to be the National Association for Agricultural Educators. They support over 542 STEM programs focused on agriculture in Missouri alone. Many of those related to robotics, coding, or other computer science related fields. 4-H is actually collaborating with Google, who's providing funding and access to computer science curriculum for well over 100,000 students in the first year alone. Missouri is on one of the lists to be one of those states involved in that program for the first year. First Robotics theme, which has strong roots here in St. Louis for this coming year in 2019, will be deep space exploration. MARSfarm is going to participate this year as judges in those competitions as well. And lastly, Project Lead the Way provides programming to engineers and computer science STEM related groups to get started, as well as one program they had last year was they received at Fox High School a $10,000 Seeds of Change grant, and we're able to, with that funding, build and then grow plants in 5 MVP food computers, which is what me and Drew had designed. They did that completely of their own volition and really just through reading the online documentation. So our product is provide teachers who are satisfied with agricultural education opportunities a chance to integrate technology in a way that emphasizes cooperation. Our product is STEM modules for building food computers and programming them to conduct specific scientific experiments while analyzing the results. Unlike any other product, these learnings are then shared with other schools and outside collaborators to show the real-world application of this research, as well as to build data sets that are attractive to companies who are interested in the long-term mission we have of putting plants on Mars. We plan to stay as lean as possible. This means that we'll share hardware designs openly and collaborate with many individuals and startups, as well as we plan to develop continue to develop our open source software stack in collaboration with others through a nonprofit we're forming based out of St. Louis called Future Ag STL. Some of the products we intend to manufacture are brain assembly, Raspberry Pi microcontroller, webcam, temperature, humidity sensors, and relays to control that actuation. We also intend to have a light module as part of our enclosure assembly to get people started growing. Our remote web application will offer services for hosted gateways into an online portal. This can be accessed locally by anyone, but the benefit of the MARSfarm service will be that remote access from anywhere. Lastly, in terms of consumables, we intend to work with the partners we have commissioned the experiments to help provide some of the seed as well as medium and nutrients intended. This will help align groups around the same experiment, and we intend to actually create what we're calling plant pillows, which are a little self-contained root zone ecosystem that we can ship an associated QR code to, and then have the food computer read that code and actuate accordingly. So our business model is to use open source materials and social platforms to attract new potential users, as well as use this to continuously audit ourselves by performing real world peer review. Already we have 18,000 views on our MVP thread and 60 people who've built our minimum viable food computer product and provided feedback. We've tested this with 5 food computers at Fox High School, as I mentioned. And we see going forward that as our customers are these primarily larger educational initiatives, as well as organizations that are driving STEM education, as well as agricultural educational programming into schools, we see those partners as being able to purchase around 5 kits at a time, which we're pricing around $899, as well as then associate those 5 devices to 50 students. Those students then will receive that online access and the ability to interact through that web portal at any time, as well as the curriculum and service fees for that as well. So we project that this will enable us to, by year 5, be making around $1.5 million in revenue. This is also taking into account additional funding rounds. We have a number of strategic relationships, including the one aforementioned with the Open Agriculture Initiative. We've also been working with the Greenhouse Venture to place food computers, as well as the St. Louis Science Center. We are collaborating with St. Louis Space Frontier, and we're the proud recipient of a St. Louis Earth Day grant, which we're using to now build and install an exhibit at the Science Center for MARSfarm. We do see that the primary competition to MARSfarm as being existing ag education that is out there. We see that right now, while this is not direct competition from a physical product point of view, it is market competition. And so we see ourselves as trying to beat that out by providing something that can be used all year round and has a higher level of engagement due to the technological interaction associated with a food computer. So things like school gardens, they really can't be utilized during the winter months. And during the summer, students aren't there to take advantage of them. We also see the primary lacking in other forms of STEM project-based learning, the real lack of real-world application for the skills learned. So while it's exciting to learn how to blink an LED using a microcontroller, it's much more exciting to blink an LED that then controls how a plant grows and see the larger ramifications of what can be done with this sort of technology. We see some of the barriers of entry that we intend to set up towards other groups as being the ability to really iterate quickly. I mentioned we want to have a lean business model. We believe that requires us to have internal prototyping capabilities. As Drew has a background in CNC machining, we see a key capability of ours to develop a CNC job shop, as well as continue our style of open innovation by having an open source software platform and long-term data platform as well. This has already helped to develop our innovations ecosystem both locally as well as internationally, and we continue to hope to see that the results of our open sourcing and the outreach that can provide us in terms of opportunities to reach out to both aerospace and plant science research communities. We see that to be tremendously exciting, and as we continue to grow closer to that community, we want to be able to pivot and continue to provide a product that is both meeting their needs as well as the needs of the end user, being the student. So thus far, we've sold 3 of the MVPs where we would build and assemble those sell those as completely assembled modules. We've also been the recipients of a 1,500 Sinless Earth Day grant, which we're using for the MARSfarm at Grow exhibit. We have not raised private capital at this point. I personally have spent around $10,000 to $15,000 in product development prior to our formation of an LLC, and Drew Thomas is committed to providing his equipment asset, which is valued around $10,000, as well as already committed $5,000 in R&D. So we do have some money in the bank, and we have rejected offers for funding previously. We're really intent on maintaining control until we have validated our assumptions both in terms of the product value and our proposed business growth model. We do want to develop relationships with potential angel investors as well as Series A investors, because we see that to be critical towards our scaling up capabilities as we progress. So we intend to utilize our proceeds for a number of things. First, we intend to formalize our business through both trademark applications as well as an IP search, and to provide vesting equity agreements for both Drew and I as well as other early founders. We plan to also promote ourselves and to attract talent. We'd like to work with Arch Grants and their network to find a co-founder potentially, as well for a full stack developer, as well as a plant scientist. We do see ourselves acquiring several physical assets with the funds. Those would be CNC equipment, which I'll speak about more in a minute, as well as a lease for a job shop where we could install that equipment and begin prototyping. So the last thing we would see is the ability to plan ahead financially. This is some, I would say, funding pre-prep work that we would like help with, potentially market research, as well as individual relationships that would be valuable for us to potentially travel to venture capitalists or other angel investors to pitch to them as well. So we'd like to leave a good chunk of our money available for that sort of future planning as well. So phase 1, we intend to get servers for our cloud-based web application. We also intend to hire consultants to take what we have in terms of curriculum and create a more polished, robust solution. We also, I mentioned, intend to establish ourselves legally and begin that marketing work around really creating our own presence online. And lastly, we intend to really use all of our funds around phases 2 through 5 to build out a job shop where we could then begin small scale production. And those are listed there below. So I encourage all of you to please join us in the most exciting journey of our time. Please invest in MARSfarm. Look at us as an opportunity to help bring the most cutting-edge technology as it relates to agriculture to the St. Louis region, as well as show the world what we've already done here. Thank you.